All right. We're going to look at electrostatic forces. This is the forces between two charged particles that are not moving. The equation looks like this. The force between those particles is equal to Coulomb's constant, which is going to be 8.99 times 10 to the 9th, Newton meters squared per Coulomb. You're going to want to store that in your calculator as K. Times the two charges multiplied together, divided by r squared. Now this is the same format as our universal law of gravitation. So we have the force is equal to big G, the mass divided by the distance squared. So they both follow this same pattern. Interesting. This equation only tells me about the magnitude. So I can only find the magnitude of the force or the magnitude of the charge. Notice the absolute value signs. I'm not going to be including negative signs on my charges. It's going to get wiped away by that absolute value sign. Or if I solve for it, I'm not going to know, is it positive or is it negative? So in order to find the direction of the force or the sign on the charge, what we're going to do is we are going to look at the charges involved. If we notice they're being repelled, I can tell you that the signs are the same. Or if the signs are the same, I can tell you that the forces are opposite in direction, okay, and are repelling. Same thing for if they're opposite charges. I know that those forces are going to be attracting, or if I see the forces are attracting, I know the charges are opposite. Okay? One thing to note here is it doesn't matter if I do Q1 then Q2 or Q2 then Q1. So what I have is I have a third law pair. These forces are opposite and equal per Newton's third law. Okay? So let's try one to see how it works. So I got two charges here. Q1 is 6 microcoulombs. Q2 is -3 microcoulombs. Now you're going to see micro and nano pretty frequently here. So just remember, micro is going to mean times 10 to the -6th, and nano is going to be times 10 to the -9th. All right. So let's go ahead and solve this. So in order to get the magnitude of the force, I'm going to use my force equation. K, Q1, Q2, absolute values divided by r squared. In order to get the direction, I simply look at the signs. And so looking at the signs, they're opposite, so they're attractive. So the force on Q1 is to the right. The force on Q2 is to the left. And these two forces have the same magnitude, which we're going to find here. So what we do is we're going to plug in our values. So I have that 8.99 times 10 to the 9th times these two charges. And again, it's absolute value here. So I'm going to have 6 times 10 to the -6th times 3 times 10 to the -6th, all divided by the distance between them squared, 0.3 squared. When I put that all together, the force comes out to be 1.8 newtons. The end. What is that sound?